try to guide my talk. So we're here talking about the quantitative reasoning section. In fact, that part of the exam comes in 2 sections, 20 questions each, 30 minutes each. As you're in one section or the other, you can freely move between the current section. You can't move between the 2 sections. And it's section-wise adaptive. So your performance on the first section helps to determine which questions you'll be asked in the second section. And if you're only asked the easier questions in the second section, you won't be able to maximize your score. I'm not quite sure what the message there is, though, because you're already going to do as best as you can on the first section. So maybe just be aware of that. But I think the takeaway is still, well, just do your best. There are 4 question types, and those are like a quantitative comparison. We will definitely practice some of those because it's different from what you would normally see probably on a math test. There's a standard multiple choice where you're given some possible responses and you pick one. There's another kind of multiple choice where you pick one or more. So pick all that apply. You will always pick at least one, but so you wouldn't ever pick none. That wouldn't be right. But sometimes they'll ask you a question and then you need to pick them all to get it right. So that's pretty amazing. So don't be freaking out if you're like, I think I need to pick all of these. It's like, that's a thing, that's fine. There's 4 content areas, and reassure yourself that this is a test of your high school math skills. Now, if you haven't done any math in 4 years, I'm not sure that's totally reassuring. But on the other hand, at least it's not a calculus exam, right? So the areas are arithmetic, which I would say they're including sort of the theory of arithmetic, like divisibility and properties of addition and multiplication, that sort of thing. Basic algebra, basic geometry, and some data analysis. So some little questions you might see in a basic statistics course. This is not a normal math test. And this is maybe one of my most important messages. This is a test that's more like a competition that you need to train for. In a normal math test, you need to show your work because you're going to get partial credit based on having a reasonable approach to the problem. You don't need to show your work on this test. You're just going to pick answers and pick them on the computer. You can use any method you want, including dumb luck, and you can get the perfectly 100% credit for that question just because you picked the right answer. Also, a normal math test is not multiple choice. So you've got to get used to focusing on the provided answers and trying to see if you could eliminate some of the answers as being completely unreasonable. So making use of the provided answers is a really important strategy. So I really think of this math test as more like a game situation. It's like playing a video game. There's all this time pressure and strategies that you've got to learn and build your skill at. So it's good that you can use any method. You just got to get the right answer and you can work backwards. But you do need to be careful because they provide you this online calculator that's a bit different from a normal calculator. You're going to want to practice their online calculator. One thing it does is it doesn't allow you to have very large numbers appear in the display. So it's kind of limited in what it can do. And dealing with the time pressure on a math test takes practice. So figuring out how to strategize that. So if you're wondering, well, so how on earth am I going to practice that? There's this amazing thing called the Power Prep. So, Power Prep software. Be sure to download and practice. Margaret, do you want to say anything about the Power Prep software? Because I never remember all the details.
It's free. It has 2 timed practice tests, and it also includes the math review, which is 100 pages, 99 pages of review of all the content on the math section, so, with questions and answers.
If you knew that you were pretty rusty on your geometry, you might work through the geometry section just for some extra practice. So is it pretty easy to find these things online?
Yes, if they just Google GRE Power Prep.
And do you have to put in the QR, or it comes with both parts, doesn't it?
It does.
I have a question. When would you recommend, because I know there's only 2 free ones, when would you recommend taking?
Oh, good question. I recommend you take when are you gonna?
Well, I'm a junior.
Okay. Well, I think you should take the first one whenever you want, as soon as possible, so that you can get a baseline, figure out what you're currently doing and what your goals are, and I have information about that. And then work to build whatever scores you need to have in between. Then you take the second one to see how you've done, and then you can repeat. Because it's 2 sections, the first one will be the same no matter how many times you take it, but you learn through taking it. So if you took the exact first one again, you get the same questions in the first part, and you get harder questions in the second. So it actually ends up being more than 2 practice tests if you think about it that way.
Because the second part will adapt,
Yes.
depending how you do on the first part.
Thank you. Yes. Does that help?
Yes.
And so, yeah, I would like, I don't know when do you need to take the exam?
It depends. What kind of grad program do you want to go into?
Biochemistry.
So it would be really good if you could take it over the summer. Because you're gonna probably have deadlines like November 1st, and you don't want to be dealing with that.
Yeah. So you've got 9 or 10 months, and so you could take it once a month or something, and just practice those video game skills, because it's just so different from a normal math test. I can't describe it, but you feel that clock ticking, because 20 questions, 30 minutes. Do the math. That's not very much time. So
35 minutes. Yeah.
Oh, 35 minutes?
Yeah.
There's a typo.
Is there?
All right. So this is so great. So my job, other than getting you to download the Power Prep, my job is just to talk a little bit about strategizing individual math questions, and maybe remind you about a little bit of high school math you might have forgotten, depending on what you've been doing lately. So let's take a look at the sample problems here. The first few that you see on the front page there, those are the quantitative comparison questions. So there's always 2 columns giving you 2 things to consider, 2 quantities, I suppose. And it's always going to be the same 4 answers. Column A is greater, column B is greater. The 2 quantities are the same, they're equal. Or you haven't given me enough information, so I'm going to pick D. So one thing you learn through practice is like, oh, it's always set up that way, and it just makes it faster when you're trying to respond to it. So check out, how about number 2? It takes X men to complete a job in 12 days. X minus 4 men require Y days to do the same job. We're supposed to compare Y with 12. Are they going to be equal? They're both measured in days. I suppose they could be equal. If you take away 4 men, in terms of a made-up math problem, you've got to assume that it's going to take more time or less time if there's fewer workers. It's going to take more time, right? Now, who knows? Maybe the 4 men they took out were just like causing trouble. Like, it'll take less time. But just tell yourself, this is not real life. This is a math problem. So if there's fewer workers, it's going to take longer. So y is how much time it's going to take compared to 12. So what are you guys thinking? A, B, C, or D? A. And doesn't it feel weird that the y ended up over there when it was second in the sentence? I kept wanting to think of it as option B. So yeah, it's A. As you're practicing, you want to be sure and use scratch paper. Don't overload your brain by just trying to do everything mentally. Yes.
So even though you really don't know if these 4 men were troublemakers, you would pick A anyway, and that would be the right
Because
answer?
it's a math problem, yes. It's like the math problem culture, right?
Okay.
So you've got to understand the culture within which you're communicating here. So yeah, you could totally like overanalyze any math problem, right?
Yeah.
And you could always be like, you know, you didn't give me enough information. I don't know if those guys work very hard or not. So no, it's just kind of like, I don't know what to say.
Like, common sense.
Yeah, just whatever would be the most basic interpretation. Maybe an example where there isn't enough information would be, give you a contrast to that. So check out number 3. Question 3 has a couple of important lessons. The first one I would stress is when you see like the angle on that diagram, there's nowhere in the words that they told me that that's a 70-degree angle. I should not assume that that central angle is frozen somehow at that specific size. What I'm supposed to learn from that picture is that A is on the circumference, B is somewhere on the circumference, O is at the center, the radius of the circle is 6, but there's no information telling me that, see how they didn't even label that angle? So you cannot assume that things in a figure are drawn to scale. Yeah, is that how we usually explain that? So don't try to read too much into that figure. You've got to somehow magically read the correct amount. So we know that we have a circle with O at the center. OA and OB are radii of 6. We're supposed to be comparing the area of the shaded portion with 6 pi minus 9 radical 5. Given that that shaded area could be different sizes, how could we possibly have enough information? On the other hand, they give us that nice online calculator, and even if it doesn't have a pi button, I know pi is like 3.14. What if I grabbed that calculator and typed 6 times 3.14, and I typed 9 times the square root of 5? It does have a square root button, right?
I'm not sure it does, but you can figure out what this.
It does? Okay.
Okay.
So if you evaluate that difference, you will learn that it's actually a negative number. And so one thing we do know is that the shaded area is bigger than a negative number.
I love that question.
That's an evil question. So A, right? The quantity in column A is greater because the one in column B is negative.
What if it had been positive?
Then definitely not enough information. Yeah, like what if they had just had 6 pi or something? And you'd be like, well, probably depends on exactly where they can be. Because when that angle gets really small, you have hardly any area. Good question. All right, so that's quantitative comparison. Let's take a look at number 5. Remember, one of the 4 areas is algebra. And some of these questions, you'll look at them and you'll be like, they want me to do algebra. Let's look at algebra question. M and men agreed to purchase a gift for $D. So on my scratch paper here, I've got M men $D. I always picture that it's this big group of brothers buying a Mother's Day present. But maybe that's just me. If 3 men drop out, how much more will each of the others, have to contribute toward the purchase of the gift? So you've got to know your own math strengths and weaknesses. If you are a very confident algebra person, this could definitely be an algebra problem. What if you know that algebra has always been a weak spot and it's going to be a weak spot and you need a different strategy? You don't have to do this problem with algebra. You could try this strategy. So strategy, if you're worried about the algebra, try some round numbers. So we can use the provided answers and some round numbers to try to make sense of the situation. M men, $D. We're also going to have M minus 3 men. We can't start with 2 men. M can't be 2. What's another nice number that's bigger than 3? Nice and round. How about 5? After 3 men drop out, we've only got 2 left. I want a number that's nice compared to about 5 and 2. What about 40? Maybe they're looking at spending $40. So before 3 men dropped out, how much would it have cost each? $8. Huh? Good job. And here, 40 over 2 would be $20. So how much more? Went up 12? Okay. Remember, we chose 5 and 40. Can we find the answer with 5 and 40 that would make 12? And don't start with necessarily the first one, maybe start with the simplest one. Like, what about part B? If we take 5 times 40, that's 200. 200 over 3 is not a perfect whole number. So I can rule that out right now, yeah? What about part A? 40 over 2 would be 20 more. No, that's not right. In fact, that D over M minus 3, that's the new amount that each remaining guy has to pay. It's not A or B. Darn, they were the easy ones. What about C? 3D, remember you got a calculator if you need it, 120. M squared is 25. 3M is 15. You're doing this on your scrap paper, so doing better. Okay. Now I judge how much time I've used already. And if I'm short on time, I'm going to just say, I'm going to go with C, right? Maybe D or E would also give me 12. So I haven't really proven that C is the right answer. But if I need to really move along, I'm just going to pick C and move on. So you got to make a game playing strategy decision, right? On D, I'll look at E. The denominator on E is negative. That's not going to work. So you can process some of these at a higher level than just punching numbers in that online calculator. Sometimes abstract thought can be quicker than number crunching. On D, D also has a negative denominator. Nice. So fairly quickly, I've settled on C, even though I've done none of the mental work to get that answer through algebra. Now you want to know how to do the algebra. But that's how you avoid the algebra, which a lot of times is faster to avoid it. Each remaining guy has to make up for the amount that was lost. The amount that was lost was 3 times D over M. I don't know, like I already feel kind of nervous about this whole thing. So I honestly think that putting in numbers is the best way to do this one. I think it'd be interesting if you guys wanted to try for yourself the algebra and see where the algebra works out. Sometimes thinking about the units helps. Does part C indicate the correct units? It's got dollars per. What's the deal with the squared min? I have a question about that. Okay. So.
Isn't that because they have different denominators and you're gonna have to?
Oh, it's like I like it. It's like from making a common denominator.
Yeah.
Yes. Good call. So the round numbers can really be a great strategy. If you don't, you get a bad feeling from this kind of algebra problem, right? If you get a bad feeling, try some round numbers, boom, you got it. All right. How about number 6? The product of 298, 754, 896, and 418 equals. So you go to your online calculator, you put in the calculation, and it says, error, I can't make a number with that many digits. So they're not going to ask you something that you can simply put into the calculator, right? So this is a question about the theory of arithmetic. What do we know about multiplying those 4 numbers together? Oh, and look at the answers. You've always got to look at your answers. They're almost exactly the same number. They just differ in the ones place. So you need to focus on the ones place of the factors. 8 times 4 is 32. 2 times 6 is 12. 2 times 8 is 16. It's got to end in a 6. Too fast?
Just one more time.
So on number 6, we're looking at 298, 754, 896, 418. I only focus on the ones places. 8 times 4 is 32. I throw away the 3. 2 times 6 is 12. I throw away the 1. 2 times 8 is 16. I focus on the 6. So I need part B, the one that ends in a 6.
You just have to know that trick to be able to.
You have to feel in your bones that when you multiply numbers by hand, those carries they affect the higher order digits, but the carries have no effect on the ones place. The ones place is only affected by the ones place of the partial products. Now, what if you weren't so sure about that fact? What's another thing that distinguishes these 5 answers? Some of them are even and some of them are odd. Is there any way this product is an odd number? No. So right there, you've eliminated 3 of the 5 answers. If you need to just flip a coin in your head and pick B or D, you can do that. That's a good one.
I like that question.
I love number 7 because it really gets to me. I don't know who designed these questions. They're pretty sneaky. The ratio of boys to girls in a class is A to B. The ratio of boys to girls is A to B. B is which? Boys or girls? B is girls. Yeah. So take your time a little bit and write these things maybe above each other. Boys to girls. B is girls. What part of the class is made up of girls? If you want to know the part of the whole, the numerator is the number of girls, right? So the numerator needs to equal B. What's the whole number of people in the class? So how do we get the denominator?
Boys plus girls.
Hmm?
Boys plus girls.
So it's going to be girls over boys plus girls. So those are some examples of just, there's one right answer, pick the right answer. And then I believe we have some, are they mixed together here? These are all just standard multiple choice, right, Margaret?
Yes.
The ones
Right,
where
yeah.
there could be one or there could be more than one right answer are quite a bit farther in, is that right?
I think that, yes.
Like 17 and 18?
Also 8.
So that's what threw me off because 8 is this other kind. It just kind of came in the middle of these, but you got to stay on your toes. You will have a visual. 8 is not really laid out visually correctly. On the exam, they'll put squares, open squares for the one or more answers, and they'll put like ovals or circles for the exactly one. So it's those open squares that can be a visual reminder that there's going to be one or more right answers. All right. I think we should try, number 9 is interesting. It's got a little bit to do with statistics. The median of 5 numbers. A, B, C, D, and E are distinct integers, so they're all different values. The median is 16. What is the minimum value of their total? Wow. This to me is a really good illustration of the fact that this is a reasoning test. So there is no formula per se that you just like, oh, I've done that problem a million times, I'm going to do this. You really need to think about this one, right? Would it help us to play around with some numbers? Can we imagine that C is the median? The A, B, C, D, and E are all being treated symmetrically, right? It's not like C really means anything different from D. It's just one of the numbers. So sometimes it might help me to imagine that C, the number in the middle, is the median, like the numbers are already sorted. So 16's in the middle. What else do we know about these numbers? They're all different from each other, but what else? They're integers in there. They're positive. If they could be negative, this would be a nonsense question, right? What's the smallest a positive number could be? 1. So if you're trying to make a plus b plus c plus d plus e small, and c is stuck at 16, what do you want to imagine the a is? 1, and then b could be really small if it was 2. Good. How small can we make d?
17.
Boom. 20, 36, 53, 54. So on my scratch paper, I don't know, I like to have a diagram or, something. Does that make sense? I'm a little bit intimidated by the way I have to read the problem without circling anything. But maybe I could jot things down on my scrap paper. But remember that they're positive. So maybe just write quick reminders. Oh, let's flip the page. Margaret, how's our time going?
We've got about 20 minutes.
Yeah. Take a peek at number 12. So this is something that mathematicians like to do to torture students. They invent these new operation symbols with no particular meaning. Well, they give them this meaning, but it's very abstract. The funny new symbol means when you put it between an A and a B, it means that you're supposed to square the two numbers and add them together.
You could just call that the Deathly Hollows.
I know, so I really.
The DH. It's the DH operator. So you take the DH of X and Y and you square that versus the DH of X squared versus Y squared. Another quantitative comparison question. So this is a basic algebra skill, which is rewriting. You have a rule for what that symbol means. Can you rewrite the expression x dhy quantity squared? Can you rewrite it without that new symbol and just go back to symbols you understand better? So instead of x symbol y in the parentheses, you should write x squared plus y squared. So we're really comparing the square of x squared plus y squared versus the square of x squared plus the square of y squared.
But can't you distribute the square thing from the outside of the parentheses together?
You actually get in trouble with that
Because of the DA?
because of, you guys remember FOIL? FOIL is a great thing to remember when you think about high school math. First times first gives you your a squared. Outer times outer gives you your AB. Inner times inner is BA. Last times last is B squared. This is 2AB. This is not the same as a squared plus B squared. There's that pesky middle term that comes from combining the AB and the BA. Okay, so when I look at x plus y, I can't remember what this was in. Oh, it was the thing. X squared plus y squared squared versus x squared squared plus y squared squared. over here, I get a middle term. 2 of the x squared y squared. Tell me about this number, 2x squared y squared. What do we know about x and y? Could they be negative? Could they be 0?
Can't be 0.
Oh, they can't be 0 because x times y is not 0, which I almost didn't even see. X, y is not 0, so x is not 0 and y is not 0. That means that this is going to make a positive contribution. Column A is going to be bigger. So even if x was negative, x squared would be positive. Tricky. If you had a middle term that could have been negative, then you'd have to say not enough information. But this middle term has to be positive. I always like to do number 15 because it's a different flavor from what we've been doing here. And it involves pizza, and we're usually doing this around 5 o'clock. A pizza may be ordered with any of 8 possible toppings. In column A, we consider the number of different ways to order a pizza with 3 different toppings. In column B, how many ways could we order a pizza with 5 different toppings? Which one of those is bigger? Is there any way they could be equal? Can we at least rule out D? Yeah. It doesn't feel like there's much in the way of unknowns here, right? Things have been nailed down. These are actually like 2 specific numbers we're comparing. There are no variables involved. So it's not D. Which one feels like it ought to be bigger? B. B, you got more toppings to deal with, right? But you know what? When you decide which 5 you want, you could just as well decide which 3 you don't want. And how to decide which 3 you want versus which 3 you don't want, it's the same number of ways. Yes, those 2 guys are equal.
I love all of these questions.
I know. And they also, they fill you with a bit of trepidation, which is maybe a good thing. It'll motivate you guys to go practice. And remember, like, if the questions are evil, like everyone has to deal with the same evil questions. It's just a matter of doing your personal best. Yeah.
Is that God's, like, the statistic idea of like 8 times 7 times 6 of the options?
No, it's got to be a combination. So what you are right about is if we cared how the toppings were arranged on the pizza, like which topping to go first, and then which topping on top of that, and then which one on top of that, and so on, there would be more with the 5 toppings.
Okay.
But because the order doesn't matter, it comes out the same. So this is a question about Pascal's triangle. Do you guys remember this guy? No. Pascal's triangle shows up in every class I teach. And he tells me how many ways I could choose a certain number of things out of a bigger set of options. So this is the number of ways to, this is the 5s row. If there were 5 toppings total, if I was going to do 5 toppings, pick one, I could do that 5 ways. If there were 5 toppings and I could pick 4, I could do that 5 ways. Because whenever I pick 4 out of 5, I could really just pick 1 to not have on my pizza. And so logically, there's this symmetry to the number of choices. Which does bring up a possible strategy. What if we had made the number of toppings smaller? What if there were only 3 toppings to choose from, and we were going to either pick 1 topping or pick 2 toppings? We could then check rather quickly. So making the number smaller is a good strategy. So there's 3 toppings available. Let's say they're ham, pepperoni, and mushrooms. So if I can only pick 1 topping, I could have a ham pizza, a pepperoni pizza, or a mushroom pizza. If I could pick 2 toppings, I could have ham and pepperoni and mushroom, or ham and mushroom. There's still only 3 ways to do it. If you have 8 toppings available, and you're going to pick 3 of 8, the numbers are kind of big. I think they're like in the hundreds. So you're not going to be able to list out the possibilities in a given time. But cutting the problem down to size, you know, maybe you mess up and the analogy is not perfect and it kind of misleads you. There's a bit of a risk, right, to trade the big numbers for the smaller numbers. But if you're really struggling on a question, it's worth having something that might work. So I think that's a really good example. How about 1 or 2 of these with multiple right answers?
I just wanted to endorse what you just said about you really have to sort of judge how much time you have to sink into something before you give up. Sometimes you can eliminate a few options.
Yeah.
And have a better chance of being correct with the others, but sometimes it's not worth sinking 20 minutes into.
Yeah, so it's you're constantly doing this calculation of cost benefit. Like, should I keep working on this? Should I guess and move on? And so there's no substitute for practicing that with the power pack, because it's like a gaming skill. So imagine you wanted to get really good at Mario Kart. You play a lot of Mario Kart. All right, let's take a look at number 27. I'm sorry, 17. Which of the following statements are false? This is number 17. I write myself a big notice on my paper. I want the false ones, right? That reversal of logic is just waiting to trip you up. Because all the rest of the questions you're focusing on what's true. Now you got to pick the false ones. So be careful. -5 is less than 31. That's not false. 0/0 is the same as 0. I guess you could actually be helpful here. What happens when you try to divide something by 0?
Doesn't this come out like unknown or unoperable?
It's undefined, yeah. It's indeterminate is what a mathematician would tell you. There is no such thing as 0/0 as a number. It doesn't make sense as a number. So that one's false, so I'm going to check it. Five to the 0 power is 1. What's the deal with the 0 power? 5 squared is 25. If I divide that by 5, I get 5 to the 1. If I divide that by 5, of course you can ask your calculator. I bet this wouldn't actually be on the test, right? But it's good to know these facts. 5 to the 0, this is why we make it defined to be 1. It just makes, it fits with the pattern. And math is all about the patterns. Oh, what would happen if you went to the -1 problem? Can we just divide 1 by 5 and get the right answer? 1 over 5? Oh, yeah. Negative exponent is 1 over, right? Cool. For positive values x and y, if y is 10% more than x, then x is 10% less than y. Better try some numbers. What are you guys going to pick for x and y? 10 and 11? 50 and 55? Call it 50 and 55. X is 50, y is 55. $55 is 10% more than 50? Yes. If you subtract 10% of 55, does it get you back to 50? Yeah, 10% of 55 is 5.5. You go back too far, you jump over the x. Oh, that one's false. Oh, this is a false. They're based on different denominators. Going forward, the denominator is 50, but going back, it's based on 55. You gotta be careful. As long as x and y are positive, if you want radical xy, you can rewrite that as radical x times radical y. We were reminded over here that you can't just distribute in every case, right? But a lot of times you can. Is this one of those times when you can't? Can you distribute the radical sign over a product? If it was addition, you could not. But you see, a radical is related to multiplication. And that's what gives you the hope. And so you could try it with a little example. What about the square root of 2 times 8? Well, those aren't very nice numbers. How about 4 times 16? $64? 2 times 4? There's an art to picking specific numbers, right? It's got to be general enough. It's got to be nice enough to be helpful. It's got to meet the requirements. It's a skill you got to practice.
Can I ask you a question that's not quite related to that, but it's related to the indicate all such statements that we have in both 17 and 18? It always strikes me that when you're confronted with 5 possible options, you have to treat each one of them as a true or false statement, which takes longer than just going until you find the right answer and moving on.
Yeah.
So I usually give the advice that if you see something like that, you might want to save it and come back to it unless you're really good at those.
This is like 5 multiple choice questions in one,
Yeah.
but at least each time it's true, false.
Yeah.
But yeah, I mean, if it doesn't feel like all of them are like snap judgments, I think that's great advice. All right.
We're almost out of time if you want to do any of them, like
Yeah.
22, 23.
I feel like the students, when they look at 21 and 22 and 23, they're like, oh my gosh, I can do these problems. I hope there's a lot of these. So those problems are just about reading a chart or a table. Wasn't there a little bit of a twist on one of them?
Yeah, it's that in 22 or 21, there's a scroll bar in the middle. And
Yes.
I copied and pasted that when I was making this, and you can just see where it's broken in the middle. And so just make sure that you don't miss information.
That's the kind of thing I'm always missing when I'm working online. It's like, oh, I didn't know I could do that. I didn't scroll down. Dang it. That's a really good point. On 19 and 20, if you've been able to calculate this in the little calculator, isn't there a button you can push to transfer the calculator answer into the box?
Yes.
So you don't have to literally type the answer, especially if it's complicated. You can just transfer the answer.
The only trick there is that you have to make sure you do it in the same form. So if it says indicated in fraction and it turns out to be a decimal, and you have to change it from 3.334 to 1/3. 0.3, whatever, you get the idea.
Oh, we could take just a quick reminder on number 20. This is related to that thing about the permutations. How many different ways can we rearrange the letters in the word traps? What's important here is that all 5 letters are different. So in any rearrangement, we've got 5 options for what we use first. But we've used it, so then there's only 4 options after that. And then there's 3, and then there's 2, and then there's 1. And you always include the original arrangement as well. So traps is one of those. And then if you subtracted 1 from this, there'd be new arrangements that make new arrangements. So 5 times 4 is 20, 60, there's 120. That's called a permutation. That's a permutation problem. The other thing with the pizza toppings, that was a combination. So you're really just choosing a subset. You don't care how the things are arranged. All right, guys. Right, maybe I should give my last word of advice here. Yeah? What I want you to do, of course, is power prep, power prep, power prep. What I want you to believe, you're smart enough to graduate from Hanover College. You can totally rock this QR test. It's simply a matter of preparation and practice. It's not a huge deal. Feel free to email me if there's something I can help you with. You could meet with a tutor in the Learning Center if you wanted to review a certain area that maybe you'd always felt weak on. So keep that in mind.
Thank you very much.
You're welcome.